Hello, I will present you my study on appearance of texturic surface using a femto laser. So I studied the appearance of surfaces that are represented here and that are given to me by Manutech. And the first thing that I did was to do microscopic photos of the surfaces to understand some of the optical effects that I saw. Textured surfaces are becoming more and more common in our in our life, and so it's very important to can control the optical properties. One of the first thing that I did was to try to measure the color using a spectrophotometer, XE7, right? And I use this one in particular because it has the option to do two measure, one with the specular reflection and another one without the specular reflection. The specular reflection is the reflection done by the light in the following the normal is what the reflective surfaces do, and it can exclude the specular reflection. We don't know exactly how, but for example, doing a hole exactly in the place that where it should start. And to illustrate the result, I will use two surfaces. One surface which is the A3, and which is reflective, and another one C4 that it's not seem to be that reflective. It's much more matte. The results agree with intuition. For example, we can see that A3 has a big gap between his reflection with the specular component and the reflection without the specular component. When in the other hand, C4, there is no big difference between the reflections with or without the specular reflection. Another thing that you can see is that there is the gap between the specular reflection and the measure without the specular reflection is much higher around the red wavelength, and it's something that is pretty visible directly by the eye, directly by yourself. After that, I asked myself to which point are those surfaces are reflective or matte, and for that I did a little visual experiment when I have a beam of light that cross each column, and we can see that in the second column the see-through surface already make the beam less glossy, and that in the column 3 the see-through surface completely cut the beam. So the column 4, it's as column 1, it doesn't really affect. So I used a gloss method to evaluate the gloss of each surface. It's simply a light source that emits light in one direction, and a receptor is exactly in the specular position that of the light. And thanks to that, I could order all the 12 surfaces, and we can see that there is six more or less surfaces that can be put labeled as reflective, and 6 others that can be labeled as matte. That all this the reflectiveness are under the one of the steel, so the treated surfaces are less glossy than the original one. After that, I saw the property of goniochromaticity in the surfaces. For example, we can see that there is 3 different colors, and so I use this experiment to can rotate the plate and see a different color each time. For example, for A2, who is a matte surface, we can see that there is a lot of different colors just by changing the position of the incident light and the observer. And for reflective surfaces like A1 is much more visible, but it's not an isotropic measure. For example, if I rotate the plate 90 degree, we can see that we have no more the rainbow that we had just before. So it's not an isotropic phenomenon. To conclude, we can say that the treatment of the surfaces can modify the color, can modify the gloss, decreasing it, even decreasing it very, very much. That some surfaces obtain a goniochromaticity. So it's their color change depending in the observation angle and the incident illumination. Thank you very much. And if you have any questions.